This video is going to look at finding the nth roots of complex numbers. And before we get started, I want to go back and review a little bit here of our roots. For example, if we had something as simple as the square root of 4, again, this stands for the principal square root, which means we're only looking for the positive answer. But here, if we were looking for positive and negative, we know the square root of 4 would be either a positive or negative 2. But we could also write this as 4 to the 1/2 power. Just like if we had the cube root of 8, we could write that as 8 to the 1/3 power. And I want you to remember this because we're going to be using the idea of these fractional exponents as a way to look at finding our roots. And if you recall the fundamental theorem of algebra, with that we said a polynomial equation of degree n. So if we have a polynomial equation with a degree of n, then that means it's going to have n solutions in the complex number system. So that's what we're going to kind of be dealing with here as far as our complex numbers. If we have the following complex number and we want to find the square roots, then because we're looking for square roots, we know that there's going to be 2 of them. If we were looking for cube roots, there would be 3. If we're looking for fourth roots, we know there would be 4 of them. So here we have our number 8 plus 8i square root of 3. And again, I'm going to put the I here in front of the square root because if we write it here after, it looks like the I is underneath. So I think it looks a little better in front. So here we have our complex number, and we want to find the square root. Now, in order to do that, we first want to convert this to trig form. And if we convert this to trig form, it's going to be rather easy to calculate the roots. So first of all, in order to do that, we're going to have to find r. And we can find the r value by looking at the square root of 8 squared plus 8 square root of 3 squared. And then we could simplify this. And this is actually going to turn out to be equal to 16. Okay, and then if we're looking for the angle theta, then we're simply just going to take the inverse tangent, okay, and that's going to be the inverse tangent of the 8 square root of 3 over 8. And we could simply put this into the calculator, and if you're in degree mode, then you're going to find out second tangent is going to give you an angle of 60 degrees. So therefore we have the r and we have the angle. Now let's make sure that this is the correct angle. If we were looking at where is this number located, 8 plus 8i squared of 3, well that means you're going to go over 8 and then also this up 8 squared of 3. So that tells us that our number is going to be here in the first quadrant. And that's really all that we're concerned with, because we know if we're in the first quadrant, it would make sense that here this angle would be 60 degrees. And of course then r is representing the distance that it's out here, so that's representing the distance from the origin to the point to equal 16. So now if we write this in trig form, we would actually have the r value, which is 16, and then that would be multiplied by the cosine of 60 degrees plus I sine of 60 degrees. And then we have to realize this is our complex number, but remember we're looking for the square roots. So that means we're going to take this and we want to find the square root, and we're going to represent that using the fraction like we did over here of 1/2. So we're going to raise this to the 1/2 power. Now, to start from here, to make this a little bit easier so I don't have to keep writing this over, I'm going to go ahead and write this using that shorthand notation I mentioned earlier, where I'm going to write this as 16 CIS 60 degrees, and then all of that is going to be raised to the 1/2 power. Because of course when we do this, this angle of 60 is going to be the same for the cosine and sine every time, so this will make things a little bit easier for us. Now, the first root that we're going to calculate, we're basically just going to use what we did with the previous video when we looked at de Moivre's theorem, when we had something raised to a power. Remember, we would take the power, which in this case is the 1/2, and we would take the 16 and raise that to the 1/2 power. And then that would be multiplied here. We would have our CIS, and then the 60 degrees would also be multiplied by, or in this case multiplied by 1/2. So then if we take 16 to the 1/2, that means we're taking the square root of 16, so that's simply going to be 4, and then we would have CIS 1/2 of 60 would just be 30 degrees. So when we do that, this here is going to represent our first root. Now, because we're looking for square roots, we know there's going to be another one. Now, we want to calculate the angle that we need to add on. Okay, and to do that, we're simply going to take 360 divided by n. And the n is representing the number of roots. Because this is a square root, that means we're actually going to take 360 degrees, and we're going to divide that by 2, which is going to be equal to 180 degrees. So we're simply going to add 180 degrees to the 30 degrees. So that means our second root would simply be 4 CIS, and then 30 plus 180, okay, is going to be equal to 210 degrees. So there's our two answers. Now, if we were to graph this to see what these complex solutions here these complex roots look like, then we're going to notice that the first one is at 30 degrees. So here's our point. This is at 30 degrees. And the other one is located at 210 degrees. And it's actually going to be right over here at 210. And that's because these roots are going to be equally spaced. So if we look here, the distance from here is 180. And then to the very next root, which is where we started, all the way back around here, is also 180 degrees. So if we happen to have cube roots or fourth roots or fifth roots, each root would be separated by the same angle. So in this case, we only have 2, so they're separated by 180 degrees. Now keep in mind when we're doing this, this is the real axis and this is the imaginary axis. And also, we could actually calculate the standard form. Right here, the 4 CIS 30 degrees and 4 CIS 210 is the trig form. And if we wanted to convert this to standard form, you could just simply go to your calculator and type in 4 cosine of 30 and then type in 4 sine of 30 degrees. And if you do that, you'll come up with the standard form. And in this case, our 30 degrees is on our unit circle. So if we went to 30 degrees, the cosine of 30 is the square root of 3 over 2. And then we're going to multiply that by 4. So let's see, that would be 4 times the cosine of 30. Okay, the cosine of 30 is the square root of 3 over 2. And then we would have plus the sine of 30 degrees, which is 1/2, so that's 1/2 I. And if we multiply this by 4, the 2 and the 4 goes to 2 square root of 3. And then 4 times 1/2 would be 2I. So this here would be the standard form. And that's given us this point here, 2 square root of 3 plus 2I. And then we could do the same thing down here. This would be 4 times the cosine of 210, and the cosine of 210 would be a negative square root of 3 over 2 minus the sine of 210, which would be, or plus really, the sine of 210 would be a negative 1/2, and that's 1/2 I. So if we multiply by 4, we're going to get a negative 2 square root of 3 and a negative 2I. So this here would be our standard form. And we can see that we have a negative 2 square root of 3, and that's going to give us the location of this point, negative 2 and a negative 2 down. So we have a negative 2 square root of 3 minus 2i. Because both of these are negative, we're in the third quadrant, and over here both of these are positive, so therefore we're in the first quadrant, and then down here in the third quadrant. All right, our next example, we're given the problem we want to actually find the fifth roots. So that means we're going to come up with 5. And if we look at the problem that's given, we have a negative 16 square root of 3 plus 16i. And once again, we first want to change this. This is standard form, so we want to change this to trig form. So that means we're going to find what is the r value, and that's going to be equal to the square root of negative 16 square root of 3 squared plus 16 squared. And once again, if we simply enter this into the calculator, you're going to end up with a value of 32. Then, of course, we need to find the angle. So that means theta is going to be equal to the inverse tangent of y over x. So in this case, that would be our imaginary over the real. So that would be 16 over negative 16 square root of 3. So we could actually simplify this first. And this would be the inverse tangent of 16s would cancel out. So that would be a negative 1 over the square root of 3. So therefore, if we go to the calculator, we would go second tangent, negative 1 divided by the square root of 3. And once again here, make sure that you are in degree mode. I want the angle to be in degrees. You certainly could use radians, but I'm going to go with degrees in this case. And we get an answer of negative 30. So we have theta equals a negative 30 degrees. Now, before we go any further, let's look at where our number is. Well, we have a negative 16 square root of 3, so this is the real, this is the imaginary. So a negative 16 square root of 3, we know we're going to be over here to the left somewhere. And then we have a positive 16i, so we're going to go up here, positive 16, which means we're going to be over here in the second quadrant. So we came up with an angle of negative 30 degrees. Well, the number we're talking about is not in the fourth quadrant. So once again, because of the domain and range for the inverse tangent, we know that this is going to be the reference angle up here of 30 degrees. Therefore, the angle we're looking for is going to be 180, because halfway around here is 180 degrees, minus the 30 degrees is going to give us our 150 degree angle. So therefore, the angle that we need to use is 150 degrees, because our angle must be in the second quadrant. Okay, so be very careful here when you're using the inverse tangent to locate the angle. Plot your point to make sure that your angle is giving you the correct quadrant. So now that we have our r and our angle, theta of 150 degrees, we now can write our complex number in trig form. So we would have our 32, and again, I'm going to use the CIS of 150 degrees. Now, once again here, this is the complex number, but now we want to raise this to what power? Well, we're looking for the fifth roots, so that means we're going to raise this to the 1/5 power. And then once again, we can use kind of Moore's theorem to actually calculate the first root. So that means we're going to simply take the 32 and we're going to raise that to the 1/5 power. And then we would take the CIS and multiply the angle 150. We're going to multiply that by the 1/5. So then if we were to take 32 to the 1/5 power, and we could use the calculator here. 32 raised to the 1/5. Now it depends on your calculator. You may need to put this 1/5 in parentheses. We get 2, which we should know the fifth root of 32 is 2 because 2 to the 5th power does equal 32. So therefore 32 to the 1/5 is 2. And then 1/5 times 150, so 150 divided by 5 is going to be equal to 30 degrees. So this here is going to give us our first root. So because we're looking for fifth roots, that means we need to find 4 more. Now, once we get to this point, just like the previous example, we need to figure out what is the angle that we need to add on. And again, that means we're going to take 360 degrees and we're going to divide that by the roots, which in this case is the n is equal to 5. So 360 divided by 5, and of course 360 divided by 5, we're going to end up with 72. So 360 divided by 5, we end up with 72. So that means we're going to add on 72 degrees each time. So here we have to add 72 degrees to the angle. So that means our next answer would be 2 CIS, and then 30 and 72 would be equal to 102 degrees. And then if we're looking for the next one, it would be 2 CIS. And then we're once again for the angle here, we're going to add on 72 degrees. So 102 plus 72 degrees is going to be 174 degrees. And then if we're looking for the fourth one, it's simply 2 CIS. And we're going to add again to 174. We're going to add on another 72 degrees. And we would end up with 246 degrees. And then for the final root, we would once again add on 72 degrees. So we would have 2 CIS 318 degrees. And again, we're going to get that by adding on 72 degrees. So now, if we were to, now again, you could multiply this out or take the cosine and sine of 30 and so forth for each one of these. So this is the trig form. You could certainly change this back to standard form if you would like. But for this case, I'm just going to leave the answer in trig form. And again, if we were to actually go and kind of plot these 5 points, we would know the first one is located over here at 30 degrees. And we said the next one was over here at 102, oops, not 120, but 102 degrees. And then we had one over here at 150 degrees. Whoops, that's not right, not 150. The next one was after 102, 174. So this is at 174 degrees. And then after that we had an angle down here of 246. And then we were over here at 318 degrees. So if we notice each one of these roots, we have 1, 2, 3, 4, 5 of them, and the angle in between, it's not quite drawn to scale here, but the angle between each one of these is 72 degrees. And that's because for each one we were adding on 72 degrees over here each time. So really, once you find the first root, like we did here, the 2 CIS of 30 degrees, we just have to take the number of roots we have, divide that into 360, and that will give us the angle that we simply add on each time to calculate the remaining roots. Okay, so once again here, if you're looking at calculating the nth roots of complex numbers, if you're given the number in standard form, you first need to convert it to trig form, and then you can kind of think of the process of using De Moivre's theorem by raising it to the 1/2, the 1/3, or whatever the 1 over nth power is that we're looking for. And you start with the first one using De Moivre's theorem. You take your R value and raise it to the power, and you simply take the power and multiply that by the angle. And once again here, that's going to give you the first root. And once we have that, you can calculate this angle that you're going to add on by simply taking 360 degrees and dividing it by the number of roots. And then you would just add that on each time. And of course, if you needed the answer in standard form, you would just enter this into the calculator, or you could go to the unit circle to calculate the standard form here of the complex number. So here we had square roots, so we ended up with two answers, and the second example we were looking for fifth roots, so therefore we ended up with a total of 5 answers.